Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example of one of the problems from section 6.2. This is on real applications of the normal distribution. So here we have a problem that says water taxi safety. When a water taxi sank in Baltimore's Inner Harbor, an investigation revealed that the safe passenger load for the water taxi was 3,500 pounds. It was also noted that the mean weight of a passenger was assumed to be 140 pounds. Assume a worst-case scenario in which all the passengers are adult men. Assume that weights of men are normally distributed with a mean of 188.6 pounds and a standard deviation of 38.9 pounds. Let's go ahead and answer these questions, and we're going to use the normal distribution, and I'm going to use both my calculator and the chart that you get from the book. For those of you that don't have the actual physical copy of the book, I'm going to go ahead and post the chart under resources for this section so you can download that chart as well. I'll be drinking a little bit of coffee during this as well. All right, so the first one says, if one man is randomly selected, find the probability that he weighs less than 174 pounds. All right, so what I want to do here is, this is part A. There's multiple ways to do this, but I always like to start off with just drawing my little distribution bell. It should be a little bit more symmetric than that because we're talking about a normal distribution, and I've got my mean. My mean weight of men is 188.6, so 188.6 is right there. So that's my mean. Now my standard deviation, I'll put that kind of off to the side here, is equal to 38.9. So you can kind of mark those off to each side if you want to. But it says, what's the probability, right here, what is the probability that that he weighs less than 174 pounds? So 174 is definitely going to be less than 188, so it's going to be somewhere over here. And then it's less than it, so we're going to shade this area over there. Now remember, half of this graph, if it was half shaded, it would be 0.5. So less than half of this graph is shaded, so I know I'm looking for a value that's less than 0.5. All right, so the first thing I want to do is, the easiest way to do this is just to use my calculator. And the way I'm going to do that is I'm just going to go to second vars, which is your distribution menu. I'm going to go to normal CDF. All right, my lower limit, this is where my shading starts. Now it starts, I always start in the left side. Now this whole left tail here is shaded, so it starts at negative infinity basically. But for this purpose, I just start with a really small negative number. It could be negative 10,000, negative 500. It doesn't really matter. This is -1 with moving the decimal place 99 places. That's what negative E99 means. It means it's -1 and then you move the decimal place 99 places. So it's a really large negative number. You can do that, or you can just simply say, this is what I usually do in my statistics class, -1 or 10,000. That's fine. That's your lower limit there because the left tail is shaded. If the left tail is shaded, you start at -10,000. The upper limit is where the shading stops. The shading is going to stop right where the weight for that guy is, which is right at 174 pounds. So 174 pounds. The mean of this distribution, they said, was 188.6, so 188.6. And the standard deviation is 38.9. 38.9. Make sure that you know your symbols and enter. So that probability certainly is less than 0.5, like we said, so it's right at 0.35. We'll go out 3 decimal places, 0.354. So the probability is 0.354. All right, and that would be your answer to part A. Now let's see if we wanted to use the table to answer this question. How would we do that? Well, the table only does it based off of z-scores, so we would have to convert this to a z-score first. And in order to do that, we would have to use our z is equal to, so the data value minus our mean all over our standard deviation. So that would be our data value, which is the 174, minus the mean, which is 188.6, divided by our standard deviation, which is 38.9. Oops, 38.9. So we have to convert it first to our standard normal distribution. And if I pull up my calculator, let's go ahead and put this in here. So clear that out. So 174 minus 188.6. Enter. Good. Divided by 38.9. Enter. So I get negative, round to 2 decimal places because our chart goes to 2 decimal places. So this is going to be negative 0.38. Negative 0.38. So negative 0.38. So this is the z-score, which means that we are negative, or we are 0.38 standard deviations to the left of our mean. That's what the z-score means. All right, so let's bring up our chart and see how to find the value on it. Now, if we look at our chart, we have a negative z-score, so that means we're going to go to table A2, which I'm already here. All right, if we had a positive z-score, we'd go to the next one, which is right there, but negative z-score. Now, this tells you, it's kind of hard to see, but this gives you the shaded area to the left, which is the one that we want. If it gave you the shaded area to the right, then we would have to find the area and subtract it from 1 because the total area is equal to 1. But it gives us the area that we want. It gives us the area to the left of the z-score that we have. So that's good. So now I'm going to just go to negative 0.38. So negative 0.3, and then I go to the 8 column, which is right here. And if you go all the way down to negative 0.38, you get 0.352. 0.352, and you will notice that that is very close, 352, to the answer that we had before. They're not going to be exact, but the chart and the calculator will generally be within a couple of 1,000ths of each other. So either one of those answers would be fine. I like to use the calculator, but if you'd like to use the chart, you can do that as well. Just remember that if you're trying to find the shaded area on the right, so if you have a shaded area that's on the right side, then when you use the chart, you find that area and then you have to subtract it from 1 because it's on the opposite side. All right, B says, with a load limit of 3,500, how many male passengers are allowed if we assume a mean of 140 pounds? Well, that's not a whole lot of statistics we have to do. That's just kind of a division problem, right? So if we do, bring up our calculator, right? So just 3,500 divided by 140, and 25, right? So if they're saying that there's a mean weight of 140 pounds, they're saying we could have 25 people on there, right? Okay, with a load limit, so B is simply, uh, oops, is simply 3,500 divided by 20, divided by 140, which is equal to, what is it, 25? Let me double check that. Yep. All right, C. With a load limit of 3,500, how many male passengers are allowed if we assume the updated mean of 188.6? Well, same kind of thing, right? So this would be 3,500 divided by 188.6. Now remember, that's a load limit, so we can't go over that. So we're going to have to round down with whatever we get. So 3,500 divided by 188.6. And so that would be round down to 18. So that would be 18 people, right? So rounded down to 18. So before, when they're assuming that the average person is 140 pounds, we can have 25 people on there and meet our 3,500 pound limit. But the fact is that with the current average weight of adults or of adult males, that if for some reason, like the soccer team went on one of these taxi boats, which isn't implausible, we could really only have 18 of these adult males before we hit our maximum capacity on the number of pounds. So yep, that's it. And then D, why is it necessary to periodically review and revise the number of passengers that are allowed to board? Because, yeah, I mean, 140 pounds is nowhere close to what the average weight of your worst case scenario is right now. And the fact is, especially in a lot of places, that humans are getting heavier. So 140 pounds may have been about the average weight of humans back in maybe the early 1900s when we were outside working all day long in the farms. But today we are probably at least on average 30, 40, 50 pounds more than that. So these things need to be updated. We need to take a look at not only the current average weights, but that standard deviation as well, because if we have a pretty large standard deviation, that means that we have a pretty big distribution between the small dates and the big small values and the big values. We might get, I don't know, maybe a basketball team that goes on a trip or something, or a football team, and we get a bunch of guys that are 250, 300 pounds or something, and they're going to end up sinking this boat. So these are all things to consider when we're talking about safety. And safety needs to be really important. So when we put a weight limit on something, whether it be a boat or an elevator or the capacity inside a restaurant or wherever it might be, we have to always be thinking about worst case scenarios and things like that. All right. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.